Trig 88 Part 2, it's still based on mathematical expectation, but there's one problem that's like long that usually people need some help getting it started. So this is number 14 in the book that I'm just trying to get you started with. It's on page 267. Information, and then the question gets a little bit morbid. So it says, functions of random variables are useful as mathematical models in the insurance business. Some of the highest paid mathematicians are the actuaries who figure out what rates you should pay for various types of insurance policies. The following is a portion of a mortality table, which means the rate at which people die. The table shows the probability that a person alive on a certain birthday will die that year before they reach the next age. So a 15-year-old has a 0.00146 chance of dying. A 16-year-old 0.00154. 17 goes up again. 18 goes up again. Bad news for you, every year you live, your chance of dying goes up. Sorry to break you some sad news. So this story is based on a group of 15-year-olds who are just, doing what 15-year-olds do. A group of 10,000 15-year-olds get together and decide to form their own life insurance company, because that's what teenagers do at parties, right? Form their own life insurance companies. So for a premium of $2 per year, $2 is what each person would pay in. They agree to pay $1,000 to the family of anybody in the group who dies while they are aged anywhere from 15 to 20, using the numbers on the chart. My director is laughing. She finds this to be a ridiculous idea, which of course it is, but actuaries actually do this. Like if you ever try to get life insurance, they'll give you a physical, they'll ask you questions about whether you smoke, they'll do a blood test, they'll want to know your height, your weight, whether you're active, and they'll decide what to charge you based on all of that. The idea being they want to make money off of you. The whole insurance industry is based on making money off of you. It's kind of like a legalized casino almost. The casino sets the games, they set the odds, they set the payouts, they set the prices, and they make money. The insurance companies, they figure out the odds, but they're going to set the prices and set the payouts, and they're going to make sure they're making money on that. And sometimes insurance is great because people get a payout, but overall, the average person loses a great amount of money on insurance because you're paying in so much more than you ever get out of it. Well, anyway, they ask you in Part A, calculate D15, the number of people expected to die while they are 15. And they want you to round that off to an integer because you can't have half a person die. So we're going to make a table. So the table should have 15, 16, 17, 18, 19, 20, and I'll take you a couple steps. You start off with 10,000 people alive, so I titled the column A for alive, 10,000 people. And your first ask is they want you to figure out how many of those 10,000 people would die. So you're going to take 10,000 times the 0.00146 from the table, and you'd show up 14.6 on your calculator. 14.6 is closer to 15, so there would be 15 people die that first year out of 10,000, and there's Part A handled for you. Part B, they want to figure out A16, the people alive on their 16th birthday, and they tell you how to do that. They say, subtract this 15 we just got from the 10,000 we started with, and there should be 9985 still alive to start their 16th birthday. Then they say, calculate in Part C, B16. We want to use the answer from B, which is this, the 9985, times the probability in the table. So we go 9985 times 0.00154, and I don't feel like doing that because now it's going to become your homework problem. I would guess this will either be like a 15 again or maybe a 16. I'd expect gradually over time you'd have more people conking out because for each year the probability goes up. There's no way these are real probabilities, because if these were real probabilities, the 16 age would have a huge jump, because if I would ask you, and eventually you'd come up with the answer if you were here, Why at 16 would there be a huge jump in teenage deaths? See if my director knows the answer. Why at 16 specifically would you expect there to be a big jump in the death rate of young people?
Car accidents?
Car accidents is correct, because they start to be behind the wheel of a car, and sometimes things happen. So I would expect a bigger bump than that at the 16 age, just because of that. But anyway, that's off topic. When you get to D, D says keep going for ages 17 to 20, just keep working this column. Take this number times the probability, and some people died. Take the alive minus the dead, start a new year. More people died. Subtract them to start a new year. Multiply, subtract to start a new year. You're going to keep zigzagging down that table. When you get to part E, they add on a column. They want you to figure out the total income each year from the $2 premiums, and they want you to figure out the outgo from the $1,000 payments. You realize, of course, if a person dies, they don't pay the $2 anymore, because dead people don't really, it's hard to collect from them. So this first year of income, there were 10,000 alive people, times $2 a piece, they put into the company $20,000. The second year, not as many people paid, because not everybody made it. So the second year, 99.85 would pay $2 to get 19,970. Every alive number would go times 2 to figure out how much income they gave the company. The outgo is caused by the deaths. So the first year, 15 deaths times 1,000, $15,000 went out. I didn't figure this number out for you. You're going to have to figure these out for yourself. But every number of deaths multiplies by 1,000, and that'll send some money out. And that's what they're talking about in E, is those columns. In F, they're asking you to find the net income for each year. So this first year, the net income, if 20,000 came in and 15,000 went out, subtract those, the company would have made $5,000. To fill down this column, we're going to do the incomes minus the outgoes, and that'll help you fill down that group. Once you do that, they ask you a question. This is going to go down every year. The company will make less money every year. They ask you to come up with 2 reasons why that's going down every year. And then on G, they're asking you what's an average year. So once you have all 6 of these answers, add them up and divide by 6. And they're asking you if that's going to be enough money for somebody full-time to want that job. And you'll see that answer soon enough. If you can manage 14, 15 is almost the same question. Just 15, they take older people. 15, they're doing 10,000 people again, but they're 55 through 59, so the chance of dying there is like 10 times higher. So you're going to get way more people dying, and then they're going to guide you through some steps. I think what they're having you figure out is how much to charge the people, maybe, if I remember that right. I think that's true. So the young people are paying $2. In this, they have you go through a similar series of steps, but your goal is to figure out what to charge the old people, and you probably would realize you should charge old people a lot more than $2 because they're dying a lot more. So if they were only paying you $2, your company would go out of business pretty fast. That'll take you through 14 and 15. The questions up through 13 are not that tremendously different from 1 to 8, but the probabilities are a little harder to figure out. They were a little bit kinder on the probabilities 1 through 8 than they are on the 9 through 12, 13 kind of group. But if you need help, email me, we'll Zoom or something.